summary, that is your orbitals basically. Okay, what is this states? Your s orbital, we have seen that it is one-fold degenerate, so 1 into 2 it can take up 2 electrons. Always whenever you want to find out electron intake, just multiply degeneracy by 2. p orbital, it is 3-fold degenerate, so you can take 6 electrons. d orbital, it is 5-fold degenerate, so it is, you can say 10 electrons can be accommodated. f orbitals can have 7-fold degeneracy, so it can take up 14 electrons. Now the full form of SPDF is sharp, principal, diffused and fundamental. Okay, similar the case for the shells. You can see here what is that. You have orbit 1, 2, 3, that is basically your shells, K, L, M, N, that is denoted by 2n square rule. Okay, so 2n square rule is very simple. You have n is your orbit, so you can put the values. So 2n square is 2 into 1 square, so that is 2. Similarly, your n is 2 for K shell, so you can write here 8. Then n is 3 for M shell, then you can write here 18. N is 4 for N shell, then you can write here 32. We have seen the cases. Okay, ionic compounds, very interesting one. How it is formed? Basically formed by the transfer of the electrons. Okay, and second thing, when there is a transfer, we have also chosen some example that we will have a look on that. Then you can say ionic compounds like NaCl, they are basically soluble in water. Okay, that is another characteristics. Then you can say ionic compounds exist in solid form generally. Okay, then the fourth point that you can think is basically aqueous solution of the ionic compounds conduct electricity. Okay, the fifth point that you can have a look, that is melting point and boiling point of the ionic compounds are high. Look here, there is a sodium. Okay, it is going to form Na plus, okay, by removing one electron. How the things comes? Let us try to relate. You were having a very simple concept, that is sodium is basically having your number 11. Okay, so what will be configuration? 2, 8 and 1. So it can easily lose this outermost electron, right? So you can write here that sodium is going to form your Na plus. How? By losing one electron. Clear? Similarly, when you talk for the chlorine, what happens? It is having atomic number 17, so you can write here 2, 8 and 7. Okay, then you can see here that chlorine basically, okay, it is going to accept one electron because it is in short of one electron. Here it is having only 7 electrons, so it is going to accept one electron and form Cl minus. Okay, and due to this reason your Na plus and Cl minus will together form the compound NaCl, that is sodium chloride, that is your common salt. That is the example of your ionic bond. See here, okay, very important, formed by the transfer of electrons. How the transfer is done? In this case, your one electron of the sodium is getting transferred to the chlorine. Look here, covalent bond is there, right? Very interesting. How to see this? Covalent bond is basically formed by sharing of electron pair. Okay, electron pair is shared in this covalent bond formation. Means what? How this all the things are written? We can see the things, that is, you have chlorine is there, okay, having atomic number 17. So you can write down 2, 8 and 7. Okay, now I can do one thing. I am discussing Cl2 molecule formation. So I have 7 electrons in outermost orbit, so I can write it like this. Okay, I have another chlorine. To distinguish it, I will put the electron as a cross. I can write 7 electrons like this. Okay, now what happens? We are discussing which bond? That is your covalent bond. What happens there? Sharing of the electron occurs, right? So here, if you see clearly, this is one electron, okay? This and this electron will come together and form the pair. So I can write it like this, okay? This is another chlorine. So you can write here. Clear? So as this chlorine is sharing only one electron pair, so what happens? There is only a single bond formation between two chlorine molecules. Clear? So this is the example of the chlorine molecule. Look here, the same case that was shown earlier, formed by the sharing of the electron pair. You can see for the oxygen, very similar case, covalent bond. You have atomic number 8. You can write 2, 6. Okay. You can write this as electrons, 6 electrons I have shown on one oxygen, 6 electrons on another oxygen. What happens? This pair and this pair will come together to form the share. Okay. And what happens? The two electron pairs are shared between two oxygen atoms, and that's why your oxygen is having the double bond in the structure. See what happens now. Ionization energy, we have seen the things, right? A very small and brief preview, that is ionization energy is minimum amount of energy required to remove electron from the isolated gaseous atom, right? It is just opposite to your electron affinity. Now we can see here that ionization energy is basically what are the factors? It is getting affected by the factors, that is first is your atomic size. Now what happens? As atomic size increases, ionization energy decreases. Why it is so? What is the reason? Look here, when your atom is there, when the size increases, what happens? Your distance of the outermost electron from the nucleus is going to increase. Okay. Now when this distance increases, then what happens? That particular electron can be very easily removed by on application of little amount of energy, and hence due to this reason, what happens? You need a very less energy, and due to this reason your ionization energy is going to decrease with increase in the atomic size. Second factor, very interesting, screening effect. What is the screening effect? Now look here, there is a nucleus, outermost electrons are there, okay? These electrons are attracted by this nucleus, but what happens? These intermediate shell electrons will basically act as a shield. It will act as a screen, okay? And when it acts as a screen, then what happens? It will not allow this electron to get inside, because when this electron tries to get near the nucleus, then it will immediately feel the repulsion due to this present electrons in the intermediate shells, okay? And due to this reason, the screening effect of the electron increases, then your ionization energy is going to decrease. Next factor is your nuclear charge. What happens when nuclear charge increases, then ionization energy also increases. There is a direct relation between the charge and the ionization energy. You can clearly understand that suppose you have, this is nucleus, this is electron, okay? Now what happens when nuclear charge is going to increase, then these electrons will be attracted by this nucleus and it cannot move freely easily, okay? And hence in order to remove these electrons, we need to supply very large amount of energy, because we have to overcome the nuclear attraction, and that is why with increase in the nuclear charge, your ionization energy is also going to increase. The fourth factor, that is the type of orbital, that is S, P, D and F. So highest ionization energy will be for S orbital, okay? We have already stated in the last lectures the difference between ionic bond and covalent bond. This bond is formed by transfer of electrons. This bond is formed by sharing of electron pair. Okay, then this is soluble in water, this is insoluble in water. Melting point of the ionic compounds are high, melting point and boiling point of the covalent compounds are low. Ionic compounds exist in solid form, covalent compound exist in liquid form. Then example is formation of NaCl, formation of O2 and Cl2 molecules that we have seen in the earlier case. Let us try to recapitulate what are the topics that are composed in entire session. So I have covered the entire topic, that is the structure of atom we have seen, orbital concept we have seen the quantum numbers, okay, then the types of orbitals, atomic number and atomic mass concepts are discussed, then shape of the orbitals are discussed, then you have ionic bond and its characteristics are discussed, covalent bond and its characteristics are discussed, metallic bond and its properties are discussed, hydrogen bond and its significance are discussed, types of crystal lattices with the examples are discussed, molecular arrangements in solid, liquid and gases are discussed, network solids including the example of diamond graphites are discussed. Then you have the ionization energy and electron affinity concepts are discussed. Aufbau principle we have covered, Hund's rule we have covered, Pauli's rule we have covered, difference between all the types of bonds, that is comparisons, are covered. Then we have covered the latest in the topics catalyst definition and its types, catalysis definition and its types, catalytic promoters, catalytic inhibitors, characteristics of catalyst, theory of the catalysis are covered. And I thank you very much for being with me, and I thank GTU heartily for giving me an opportunity to deliver my lecture in this noble mission. Thank you so much.